Unit 2 video, page 60 to 62. Connections between f of x and f prime of x for polynomial and trigonometric functions. So this table above we've already kind of talked about, but we're going to reiterate. If f prime of x is equal to 0, then f of x has a horizontal tangent line, i.e. a relative min or max, provided that f of x is a polynomial function. Right? If f prime of x is greater than 0, then f of x is increasing. If f prime of x is less than 0, then f of x is decreasing. If f prime of x changes from positive to negative, then f of x changes from increasing to decreasing, meaning there is a relative max. And if f prime of x changes from negative to positive, then f of x changes from decreasing to increasing, meaning there is a relative min. All right, so looking at this graph, the bottom of the page, this is a graph of f of x. Okay, and we're going to use this graph of f of x to help us sketch a possible graph of f prime of x. Okay, so first things that we're going to look at are when does f of x have a relative max or relative min, right? So when does f prime of x equal 0? So that happens here, here, and here. So that's negative 4, 1, and 5. So if these are when we have horizontal tangents, right, the slope is 0, that means that those are where f prime of x equals 0. So f prime of x will be 0, and negative 4, 1, and 5. Now all we got to do is identify what's happening to the left and right of those zeros. So to the left of 4, f prime of x is increasing. So f of x is increasing, so f prime of x is positive. So we'll draw a positive line, which just means it's above the x-axis. To the right of negative 4, f of x is decreasing. So we're going to be under our graph until we get to 1. And then we're increasing again, so we'll be above our graph. So we need to be under our graph until we get to 1, and then back above our graph until we get to 5, and then below our graph. Okay, so we're increasing, so we're positive. We're decreasing, so we're negative. Increasing, so positive. and then decreasing again, so negative. All right. So pictured below is the graph of the function f of x. Answer the questions that follow about f prime of x. Okay, so we're going to do the whole left side of the sheet. The right side I'm going to leave for you to do on your own. So if this is f of x, this is our graph of f of x. We're going to use this graph to help us figure out some information about f prime of x. So first thing we want to do is approximate the value of f prime of 4. All right, so approximating x prime of 4, we're here. So we want to know, in this case, what the slope at f of 4 is. So there are a few ways we could do this. We could sketch the slope and do it that way, or we can find the slope of the secant. Since we know 2 points on this graph, we can use the slope of the secant line to help us estimate the slope of this tangent line. Because remember, the slope of the secant is parallel to the slope of this tangent at a given point. So we're going to use these 2 points here. This is 5, 4, and this is 3, -1. So we'll use those 2 points to help us out because we know that f prime of 4 is approximately equal to the slope of the secant line passing through 3, -1 and 5, So f prime of 4 is approximately equal to y2 minus y1 over x2 minus x1, which is approximately equal to 5 over 2. All right, now we want to know at what values of x is f prime of x equal to 0 and justify your answer. So we're going to justify before. We're going to justify before we actually write our answers. So to justify this, we know that if f prime of x is equal to 0, then f of x has a relative max or min. So looking at the graph, we can see that the relative max or mins occur at x equals -4, 1, and 5. Now we want to know on what open intervals does f prime of x less than 0. Justify your answer. So again, we're going to start with justification. So if f prime of x is less than 0, then f of x is decreasing. And that occurs, so which occurs on the interval -4 to 1 and 5 to infinity. All right, now we want to know on what open intervals is f prime of x greater than 0. Justify your answer. So again, we're going to justify use first, and then we're going to tell what our justification means. So if f prime of x is greater than 0, then f of x is increasing, which occurs on the interval -infinity to -4 and 1 to 5. Okay, so now we want to know at what values of x does the graph of f prime of x go from being below the x-axis to above the x-axis. So if our f prime of x is going from below the x-axis to above the x-axis, then we have, excuse me, we have a relative min. So we're going to start with the justification. So if f prime of x changes from negative to positive, then f of x has a relative min, which occurs at x equals 1. Okay. And then last but not least, at what value of x does the graph of f prime of x go from being above the x-axis to below the x-axis? We'll start with justification. So if f prime of x changes from negative to positive, then f of x has a relative max, which occurs at x equals -4 and 5. All right, so now what I want you all to do is looking now at this graph to the right. This is a graph of some function f prime of x. It is in no relation to the graph to the left. Okay, you're going to answer these questions knowing that this is a derivative graph. This is not the original function. Answer the questions below. Okay. Now for our last page, page 62. Again, we're only going to do one side of this page. We're going to do the I guess we will do the left side to be nice. Yeah, we'll do the left side. We'll do number 2. So for each of the given functions, determine the intervals on which f of x is increasing and or decreasing. Find all coordinates of the relative extrema. Unless otherwise noted, perform the analysis on all values on the interval negative infinity to positive infinity and provide justification for your answers. So this is asking for a lot of information. So we're going to look at problem number 2, where we have f of theta equals theta plus 2 sine theta on the interval 0 to 2 pi. So instead of performing the analysis on all values from negative infinity to infinity, number 2 specifically asks for just 0 to 2 pi. Okay, so to start this problem, we want to first find the derivative. So we want f prime of theta. And we're going to use the power rule and some trig information to help us find f prime of theta. So the derivative of theta is just 1 plus, bring up the 2, derivative of sine is cosine. So that is our derivative. Now what we're going to do is try to find the relative extrema. So we're looking for maxes and mins. So in order to do that, we need to set our derivative equal to 0. Okay, now we're just going to solve for theta. So subtract 1, get negative 1 equals 2 cosine theta. So negative 1/2 equals cosine theta. And if we look at our unit circle, cosine is equal to negative 1/2 when theta equals 2 pi over 3 and 4 pi over 3. All right, so now that we have our relative extrema, we know that those are when we have horizontal tangents. So we're going to use that information on a number line of sorts to help us to figure out what's happening. So this number line is going to go from 0 to 2 pi because that's the interval that we're looking at. And we know that we have a 0 at 2 pi over 3 and a 0 at 4 pi over 3. Okay, so up here, we're looking to plug in some numbers into f prime of theta, not of x. We're looking to plug in some numbers into f prime of theta to figure out if we're positive or negative when it comes to the derivative. So between 0 and 2 pi over 3, I'm going to just plug in pi over 2. So we'll have 1, actually let me do this in a different color. We'll have 1 plus 2 cosine pi over 2. And that'll give us a positive value. All right, between 2 pi over 3 and 4 pi over 3, I'm going to plug in a value of pi. So we'll have 1 plus 2 cosine pi, and that will give me a negative value. And between 4 pi over 3 and 2 pi, I'm going to plug in 3 pi over 2. So we'll have 1 plus 2 cosine 3 pi over 2, and that'll give me another positive result. So if we are to analyze this information, we can see that f of theta is increasing on the intervals from 0 to 2 pi over 3 and 4 pi over 3 to 2 pi, because f prime of theta is greater than 0. Okay, so analysis includes increasing, decreasing the relative maxes and the relative mins. Okay, so now we're going to look at when f of theta is decreasing. And that is on the interval from 2 pi over 3 to 4 pi over 3. And that's because f prime of theta is less than 0. All right, now we're going to look at the relative maxes and mins, if any exist. So f of theta has a relative max at x equals 2 pi over 3, because f prime of theta changes from positive to negative. Okay. So now that we've identified where the relative max is, we want to actually find out what the point is. So to find that, we know that x is equal to 2 pi over 3 at the relative max. So what we're going to do is we're going to plug that into our original function. Okay, so then we have f of 2 pi over 3 is equal to 2 pi over 3 plus 2 sine of 2 pi over 3, which is equal to 2 pi over 3 plus square root of 3. So our relative max occurs at the point 2 pi over 3, comma 2 pi over 3 plus square root of 3. All right, so we found our relative max. Now we need our relative min. So f of theta has a relative min at x equals 4 pi over 3, because f prime of theta changes from negative to positive. And again, we're going to use this value and plug it into f of theta to find the actual point for our relative min. So f of 4 pi over 3 equal to 4 pi over 3 plus 2 sine of 4 pi over 3, which is equal to 4 pi over 3 minus square root of 3. So our relative min occurs at 4 pi over 3, comma, 4 pi over 3 minus square root of 3. All right, so we have completed the analysis of this function. We found the increasing intervals, the decreasing intervals, the exact relative max, and the exact relative min. Okay, so you're going to do similar process to part 1. First, you want to find the derivative using the power rule, find the zeros of that derivative, make the number line, figure out positive and negative intervals, and then do your analysis.